Hello everyone, Mr. Minnick is my name, math is my game. Today, what we're going to be doing in Algebra 2 is studying how to simplify radicals. It has nothing to do with dictators or world leaders who have ideas that are totally out of the norm. We're going to be taking square roots and breaking them down the right way. So hopefully everybody is ready to rock and roll with this. You'll notice that I have a calculator program that actually did do some radical simplification for me. That was my TI Nspire CAS. That's one of the many reasons the TI Nspire CAS is not allowed on tests. So anyway, when you simplify square roots, how do you do that? Why do you do that? What kind of answers do we expect and that kind of thing? So that's where we're going with this. Okay. So the title is Simplifying Radicals. If you want to jot down those three examples, and as we go through this, I'm sure you'll realize why they are what they are, why the square root of 75 breaks down the way it does, and why the square root of 6 doesn't break down the way it doesn't, and why the square root of 200 breaks down the way it breaks down. So in the course of the next 20 some odd minutes, you will be able to simplify radicals. Now, with this being an Algebra 2 class, remember that geometry is a prerequisite. Chances are you simplified radicals in geometry, and chances are you probably forgot that. So here we go. First of all, the radical sign. There it is. This is what it looks like if you've never seen one in your life. Well, there you go. I'm sure everyone's seen that, though. One thing that may surprise you is that there is a number in the notch right here. When we talk about the index, it's the number in the notch. Right in there, there's a number. Believe it or not, if there's an index. Does anyone know what that number really is, even though we don't have to write it? It's not 1. We would think it's 1. It's not 12. I don't know where 12 came from. It's just a random guess, but the number that's under the square root is the radicand. Well, yeah, the number under the square root, like in this case, if we had an 8 here, 8 would be the radicand, okay? But what number is the index? What number is in that little notch that's not there? If I call time out and I say, let's think about this, what does that radical sign mean? It means we're taking what kind of root? The square root. So what do you reckon's in there? There's a 2 in there, okay? Later on, in an upcoming chapter, we're going to look at something like this, and this would be called the cubed root. Okay? And the index there would be 3. So when the index isn't written, when the index is not written, by default, the index is a 2. But we don't need to write it when it's a 2 because everybody knows it means square root. Okay? We doing all right? Okay. Well, factors of a number. This is a skill that you learned in factoring, so I'm not going to spend a whole bunch of time, but you do need to know what factors of a number are. For instance, if we think about the number ocho, ocho's got a few factors. 1's a factor of it, 2's a factor of it, 4's a factor of it, and 8's a factor of it. But when we find factors of numbers, it's most helpful, most useful, most commonly what we do is we see if it's divisible by 1, yes it is. If it's divisible by 2, yes it is. And then what we do is we kind of examine pairs of factors. We look at the 1 and 8 and we look at the 2 and 4. Okay, we did that when we factor, and we're going to do that when we simplify square roots. So if you cannot find factors of a number, you're going to really struggle with simplifying square roots. I'll say that again. If you have a hard time finding factors of a number, you're going to have a hard time simplifying a square root. Okay, so let's just try a couple of these. Example, find factors of 450. So of course it's divisible by 1 because every integer in the whole wide world is divisible by 1. Now, is 450 divisible by 2? A number in general is divisible by 2 if that number is even, and 450 certainly is even, so this is certainly divisible by 2. How many times? 225. Now, if I knew a thing or two about simplifying the radicals, what I would do now, oh man, I don't have one. I need to get one. I need to go to the worldwide inner line on the web, on the line, and get something offline. I need a stop sign. So I'll get a goggle image of a stop sign if the internet works. I bet the internet's going to go faster than traffic today. So the reason I made that comment is we're actually on a 2-hour delay today because of the weather. Well, apparently the internet's not going to be faster than traffic today. So what I would do at this point, if I was simplifying a square root, is I would stop. Can anyone tell me why I would stop? Because 225 is a perfect square. Yeah. So let's think back. Perfect squares. Perfect squares. If you forgot those 20 perfect squares, here's your chance to remember again, because I'm going to give you that quiz that you had the other week ago. I'm going to give that quiz again this week. And I'm going to put it in the grade as a test grade. 20 perfect squares. The first 20. 1. What's the second perfect square? 4, and then 9, 16, 25, 36, 49, 64, 81, 100. That's the first 10. And then we go to 121, 144, 1 what? Okay. And then 196. 220. Oh yeah, so 225 is a perfect square. Good. And then 256, and then 289, and then got awful quiet. How about 324, 361, and 400? Okay. If you don't recognize those, you're going to struggle with simplifying radicals. So simplifying radicals combines factoring with perfect squares. So I think that the thing that's going to give most people the biggest struggle is A, factoring, and then B, recognizing these perfect squares. If you can do those two things, simplifying radicals is just really one step further than that. Well, it's 2 or 3 steps, but once you understand the process, the skills required, the skills involved in this, it's real easy, real easy. But again, you've got to be able to find factors of 450. Maybe you got to be able to find factors of 675. What are some factors of 675? 1 and 675. Now, is 675 divisible by 2? No, it's not. Is it divisible by 3? It is. Is it 225 times? Hold on a minute. 3 into 675. That's 2. That's 6. Bring down to 7. That's 2. That's 6. That's 1. It's actually 220. 220. It is 225, isn't it? Oh. Okay. Well, let's try another one. Let's try simplifying a number like or finding factors of a number like 72. 72, what, is it divisible by 1? Of course it is, 1 and 72. How about 2? 2 and 36. 3 goes into 72, believe it or not, 24 times. 4 goes into it half as many times as 2 did. 5 doesn't. 6 goes into it 12 times. And 7 doesn't go into it, but 8 does 9 times. It is a lot, but we could have stopped after the second pair. We should have stopped at this point right here. We should have really stopped at that point right there, okay? Some people aren't going to. So what are you talking about, Mr. Minnick? Well, let's see. Simplest radical form. You really need to know what simplest radical form means. and this is the first part. There's more to it, but this is the gist of what we're going after today. Simplest radical form means the radicand means the radicand has. No, that means none. Perfect square factors larger than the number 1. So what I'm saying is, if you have to simplify a radical, and there's a number under the square root sign, that's the radicand, you need to know that number's factors to determine whether or not it needs simplified. Sometimes it'll need simplified, and sometimes it won't. If we go back to the beginning, square root of 6 is the square root of 6. Why? Well, let's look at 6's factors. 6 breaks down into 1 and 6 and 2 and 3. 1's a perfect square, but 2's not, 3's not, and 6 isn't. So what simplest radical form means is that if there is a number under the square root, that it doesn't have any factors bigger than 1 that are perfect squares. Okay. Are there any questions about that concept? Because there's going to be some of these things where we don't have to simplify them. Some of them are going to even be even numbers, and you're going to say, well, it's even, it's got to simplify. No, it doesn't. Some of them are even going to be multiples of 5, and you're going to say, well, it's a multiple of 5, so it should simplify. No, it might not. Okay. So here it is. Here's what is leading up to the procedure, the algorithm. There's this thing called the product property of radicals, and it's really, it's to simplifying radicals as the zero product property is to solving equations by factoring. What it says is if we have the square root of any number a, as long as a is positive, or not negative, I should say, a times b, that we could break the radicals up into the square root of a times the square root of b. Now that statement is true in both directions. It's actually a biconditional statement. What we mean by that is if you had something like the square root of 25 times 2, that's the same thing as the square root of 25 times the square root of 2. What that also means is if we had something like the square root of 8 times the square root of 9, that's the same thing as the square root of 8 times 9. Okay, so this property, it's kind of confusing at times, but it really, using the property in this way is really what we're going to be doing to simplify square roots. Okay, using it that way is predominantly how we're going to simplify square roots. Okay, how we doing? All right. So here it is. Here is the algorithm, the procedure, the 4-step procedure that will make you a professional radical simplifier. Is that a word, a radical simplifier? You will be a professional radical simplifier if you can do these 4 steps. And I tried to, well, let's see. There we go. Hopefully that's big enough for everyone in the back to see. Step 1 is find the factors of the radicand. I said factoring's a skill, a key component of doing this. If you don't find the factors, then you can't do this. While looking for those factors, what you should be after is the pair of factors that has the largest perfect square. So again, knowing your perfect squares is a very critical skill. After you've done step 1, step 2, you're going to rewrite the radicand, and that actually means writing something down. Now, some of you are going to get really good at this really soon, really fast, and you're going to skip some steps, and you're going to mess them up. And you're going to say, well, where did I go wrong? And I say, well, you didn't write anything down. I don't know where you went wrong. Step 2, I would like you to rewrite the radicand. In other words, write again the square root of something as the product of, that means multiply, as the product of those factors. And when you do that, sometimes the perfect square factor is going to be the one on the left. Sometimes it's going to be the one on the right. But I do want you to write the perfect square factor before you write the other factor. And you'll see why. Once you get good enough at these, you're going to combine steps 2 and 3 and even 4. So you're not going to have to do this necessarily in a 4-step process. Step 1, there's no way around that. So at some point you'll get good enough at these you can combine steps 2, 3, and 4. But in step 3 you split the radicand into 2 radicals. And if you do that, in step 4 what you'll have is a square root with a perfect square in there. And that term is going to simplify. The other term is not going to simplify. And that'll be it. So it's a real simple 4-step process. People want to skip steps. People want to not do number 1. People don't want to do number 2. Not doing number 2 is the reason that most people get these backwards. They're all really interconnected, interrelated. But the most common mistake that people make is to put the wrong thing under the radical. So I'll leave that up there for another minute or so. And we'll look at a couple of examples, and that probably ought to be it. You might actually have some time to get started on the worksheet on this. There is a front and a back to the worksheet. I did have a 6-page worksheet, but I didn't want to make 80 copies of that. So here we go. Let's go split screen so that we can see the steps. And in our first example, we're going to be simplifying the square root of 72. So remember what step 1 asks of you. Step 1 says you've got to find factors of 72. 1 and 72. And let's ask ourselves, are there any perfect squares there? Well, yes, there is. 1 is actually a perfect square. Right? But we're looking for not any old perfect square. We're looking for the largest perfect square. So let's keep on trucking. Hey, I know that 4 and 18 work. 4 is a perfect square, so let's use 4 and 18, huh? Why not? Because it's not the biggest? Well, let's use it and see what happens. Let's use it and see what happens. Let's use it and see what happens. So here's step 2. Here's step 2. It's the square root of 4 times 18. And I did write the perfect square first, right? Step 3, it's the square root of 4 times the square root of 18. Step 4, what's the square root of 4? 2. So it's 2 times the square root of 18. So who can tell me what's wrong with that? It's not as simple as it could be. Why not? Because 18's got perfect square factors bigger than 1? Really? So, oh, son of a gun. Well, that's going to suck. So I got to do this again. So start again. So start over. So it's 2 times the square root of 9 times 2. So it's 2 times the square root of 9 times the square root of 2. So it's 2 times 3 times the square root of 2. So it's 6 times the square root of 2. Who can tell me why in step 1 I wrote what I wrote? See the part where it says, look for the pair that contain the largest perfect square? Why did I write that? So why? So I don't have to do what I just did. So I only do that one time, right? It's still right, but you end up doing more work than you should have had to do. So what factors should I have gone with? 2 and 36. 36 is a perfect square. It's the biggest perfect square. Ding, 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 ding. We have our winner. So step 2 then should have looked like this. Step 2. It's the square root. Should I write 2 times 36 or 36 times 2? 36 times 2. I always put the perfect square first. Why? Because it just makes it easier that way. Step 3, we break them apart. Rad 36, rad 2. Step 4, we're almost done. What's the square root of 36? Here's another place where people screw this up. I want to bring great attention to this. The second you simplify a radical, when we go from the square root of 36 to what it equals, a lot of people think that the square root sign still follows. No, it doesn't. The square root of 36 is just plain old 6. There's no more square root, and a lot of people still put it there, and they screw these up. What about the square root of 2? It's just the square root of 2, and it just goes along for the ride, and that's it, we're done. We get the same answer that we got the other minute ago, but it's a heck of a lot easier if you follow these steps, isn't it? All right, let's try another one. Are there any questions about that? Now, here's a question. On tonight's homework, if you were to put that the answer is 8 point something, what do you reckon I'm going to give you in the grade book? A 0. No decimals. We're not getting decimal answers. This is varsity math, and we're getting exact answers, okay? So let's try to break down rad 8. Let's try to break down rad 8. 8's 1 and 8. 1's a perfect square, but it's not the biggest one, I don't think. 2 and 4. 4 is the biggest perfect square factor. So we're going to have the square root of what times what? 4 times 2, which is the square root of 4 times the square root of 2. So our final answer is 2 rad 2. Bam, like a bows. This isn't bad, is it? I love this one. I really want to go back into sales. I feel like Vince from Slap Chop. Square root of 200, square root of 300, square root of 500. You ready? These are all real easy. 200 is going to be it's going to be 2 times 100, right? So it's going to be square root of 100 times 2. Square root of 100, square root of 2, so it's going to be 10 rad 2, right? Do we see a pattern here? So what's square root of 300 going to be? 10 rad 3. Square root of 500? 10 rad 5. So what about the square root of 400? It's not 10 rad 4, because it's a perfect square. It's 10 times 2, which is 20, right? I really miss sales. Okay. Here's our last example. Square root of 42. 1 and 42, 2 and 21, 3 and 14. 4 doesn't go into it because 2 didn't evenly. 5 doesn't because it doesn't end in a 0 or 5, but 6 does 7 times. So 1's a perfect square. So what's the square root of 42 simplified equal? It's just the square root of 42. You can't do it. Whoa, hello. It's just the square root of 42. Bam, that's it. It's been real. It's been fun. I hope you found this educational. I will be posting this on my YouTube channel. Have a great, terrific day.